Hi! In this video we will be talking a little bit about the RMSE and doing a problem related to it. So what is our scenario? Our scenario is we are at a party and we measure two things. We measure the number of words slurred that someone says, so number of slurred words, and we also measure the number of drinks consumed. And the mean and standard deviation of each of these, so the average is 20 for number of slurred words and 4 for number of drinks, and the standard deviation is 5 for number of slurred words and 1 for number of drinks. And let's go ahead and we'll call these x and y, right? We always make x the thing we want to predict from and y the thing we want to predict. So we would like to predict number of words they slur given the number of drinks they consume. This seems more reasonable than the other way around. So now, suppose I don't know anything about x. Know nothing about x, hypothetically. But I want to do something with y, and I ask you what percentage of people, what percent slur more than 30 words? Well, we know how to do that. We don't even have to worry about regression or RMSE yet. We just say in z-scores 30 minus the mean 20 divided by the standard deviation is 2. Well, then we use normal table, and we see that the answer is 2.5%. 2.5%. But now we do know something about x. We know that the average is 4 and the standard deviation is 1. But we need to know one more thing to actually use it in predicting y. We have to know r, the correlation between these two things. So suppose r, so we have r is 0.6. Well, now we can do something with this. So I can ask you the same question. So if r is 0.6, now I ask you, again, what percent slur more than 30 words, greater than 30 words, 30, let's erase that mistake, so greater than 30 words. Now I want to say given 30 words, given that they've had 6 drinks. When they've had 6 drinks. There you go. And so now we can actually say more than before. Here it was 2.5%. Why was it 2.5%? Well, if I draw a normal curve, that's 2 standard deviations, that's -2. We know that 95% is in the middle, so 2.5% is here, and 2.5% is here. So back to our question, what percentage slur more than 30 words given that they've had 6 drinks? Well, 6 drinks is 2 standard units away from the mean. Why? Because 6 minus 4, that's the average number of drinks. Average. It's actually the average x, right? Because we made average drinks x, divided by 2, standard deviation of x. Oh, sorry, that should be 1 is the standard deviation of x divided by 1 is equal to 2. So we get 2 standard units from. Now, do we just go and predict that they've had 2 standard units more, they slur 2 standard units more words? No, we don't. Remember, a standard unit just means number of standard deviations from the mean. But we have to use our regression rule. So the regression rule tells us that our predicted y in standard units is r times 2, which is 0.6 times 2, and that's 1.2. So now we know that our predicted y in standard units, which is number of words slurred, is 1.2. So the next step is to de-standardize. Now remember that, so that gives us 1.2 is in standard units, and that's our actual value of y. Let's just call it y, minus the average of y over the standard deviation of y. That's 1.2. So now we can solve, and we get y is equal to SD y times 1.2 plus the average of y. Now that is 20, and that is 5. So this gives us 26. So our predicted number of words slurred is 26 when they've had 6 drinks. That's part 1. Part 2 is, what if I ask you, well, I did ask you, what percentage do we expect to slur more than 30 words? Well, that's where the RMSE comes in. RMSE. So the RMSE is equal to square root of 1 minus r squared times the standard deviation of y. Well, we know what the standard deviation of y is. This guy is 5. And this guy in here, well, r is 0.6, so this is 0.36. And this guy is 1. So this whole thing is square root of 0.64. That's 0.8. So 0.8 times 5. So the RMSE is 4, right? The RMSE is always lower than the standard deviation of y if knowing x tells us anything about y. That's not 5, that's 4. Right? So we know a little bit extra. In pictures, if we draw our data, looks like a football. Right? Nice little football. Some people say it looks kind of like a sausage. Our regression line looks like this. Remember, it doesn't look like the SD line, which looks like this. Kind of skewers that sausage. Then the RMSE is the spread of the data along any vertical strip. So say we go out here. It's less spread out than the data overall because I go like this. Now if I flip it, then what I get is a normal curve with mean your prediction, in this case 26, and standard deviation is the RMSE. So this is the RMSE. That's this distance over here. So that's why we can use the RMSE to do our nice little normal curve tricks. So we go back to the question, which I'll write again. What percent slur more than 30 words if they have had 6 drinks. Right? So that's this. We're cutting this vertical strip. We're looking at this distribution with an average of 26 and a standard deviation of 4. So now we say, well, 30 minus, so 30 is our the value we want, minus the average, which is 26, divided by our RMSE, which is 4. That's 4 on the top and 4 on the bottom, so that's 1 standard unit, so it's 1 RMSE away from our predicted value. If we draw our normal curve, right, the empirical rule tells us that 68% lies within 1 standard deviation of the mean, which means that 32% lies on either side. It's symmetric, although not quite as I've drawn it. So that means that this area over here, let's make that a different color, this area over here is 16%. And that concludes this part of the problem.